Okay, look at question number 16. You are asked to find the coordinate of the point of intersection between the curve y equal to x squared plus 1 and y equal to 2x plus 1. Okay, so we try to find the point of intersection, solve simultaneous equation. This one no problem. So you just solve, you get this one, and then you for point of intersection you get the x, you will get the y, x you get the y. So these are the points of intersection. Okay, then after that, if y1 is the volume of the solid generated, if the area of the curve, okay, the area bounded by the curve and the line is rotated through 360 degrees about the x-axis. V1 is rotated about the x-axis. Well, V2 is the volume of the solid generated if the area bounded by the curve and the line is rotated about the y-axis. So y-axis you rotate, you get V2. You rotate at x-axis, you get V1. So first of all, you sketch the curve, and then one is parabola, the other one is a straight line. Then I think this one should be no problem. So you get something like this. Okay. Now, parabola and the straight line, and then the point of intersection 0, 1 and 2, 5. So 2 and 5. Okay. So now what we want to do now? We want to find the V1. What is V1? V1 is already stated in the question. Is the solid generated if the area bounded by the curve, and the straight line, isn't it? And the straight line is rotate 360 degrees about the x-axis. So you rotate about the x-axis. So when you rotate about the x-axis, so this is the formula. X-axis dx, y2 square minus y1 square. Okay. So this, the y is here. So the top one minus the bottom one. So y2 square red color, y1 square red, black color. So here you have to square it because you want to find the volume. You need to square the y. Okay, so you square here, and the red and the black one both. And then the limit is from 0 to 2, the dx. Okay, so the dx is, so I substitute this one, 2x plus 1 square, I square it, and then this one also I square, then I substitute, then I expand and I simplify. After that 0 to 2, then after that I integrate, then I substitute 2 and 0 don't need to substitute, then I get this is the answer when you rotate about the x-axis. Okay, now I want to find what is the volume when I rotate about the y-axis. So same area, the curve, the parabola and the straight line. So you want to rotate about the y-axis. The formula is this one, dy. So x2 square minus x. That means you have to take the x, x. So this is x2 square. So but the square, the x already got square, so you don't have to square anymore. So it's just y minus 1 because it's already square. But here the x has no square, so you have to square it. So you get this. Okay, you find the x, you square it. So after that you substitute. You see the black color, y minus 1, because the square, the x already squared, but here no. So you square it, and then the limit is from 1 to 5. Then after that you just expand. See how you expand? You know how to expand this one. So you expand and then you simplify, you get this. After that you integrate, then you substitute the limit. Okay, you substitute the limit, you get all this. After that I use calculator, I get this is the answer. Okay, but now the question is, you are not asked to find V1 and V2. We want to find V1, the ratio V1 to V2. So if you want to find the ratio V1 to V2, so what we do, you divide. So just now this is the V1, the answer for V1 just now. And then V2, this is the answer. So we simplify, you can cancel, simplify, get 13 over 5. So V1, V2, 13 over 5, the ratio is 13 to 5. That's all. Okay, so I think you can do, and you can try first until question number 20. Okay, then I will give you example on 21, and I will choose a few questions later. So today you can do until number 20.